Hello everyone, welcome back to my channel. My name is TJ Astrophysics. I'm a student at LLFP, and today we're going to be discussing black holes. Before we get started, I did get a new microphone, so let me know if the sound is any better in the comments down below. Stephen Hawking said in his book Brief Answers to Big Questions, it is said that fact is sometimes stranger than fiction, and nowhere is that more true than in the case of black holes. Black holes are stranger than anything dreamed up by science fiction writers, but are firmly matters of science fact. So today, we're going to have a deeper look on what black holes are by understanding their structures and effects on the universe. So first of all, we're going to see how a black hole forms, and then we're going to see how they're structured, and then we're going to see the different types of black holes, and finally we're going to ask ourselves what happens when we throw something into a black hole. So how are black holes formed? First, to understand how black holes are formed, we have to understand how stars die. So stars remain stable because of the perfect balance between the force of nuclear fusion pushing outwards of the star and the force of gravity pushing inwards of the star. What happens when a star dies is that the force of nuclear fusion isn't strong enough to withstand the force of gravity. Hence, the star collapses into itself. The death of a star can lead to multiple outcomes depending on its mass. If the mass of the star is anywhere between 0.5 and 8 solar masses, it will result in a planetary nebula leaving behind a white dwarf. If the star has anywhere between 8 and 25 solar masses, it will create a supernova type 1, leaving behind a neutron star. But if the star has more than 25 solar masses, it will create a supernova type 2, leaving behind a black hole. For more details on how stars die and how black holes form, watch my other video on stellar evolution. But how exactly does that work? How does a star turn into a black hole? Here's a common analogy. If you have a cannonball and you shoot it straight up to the sky, eventually it's going to come back down, right? If you shoot it faster, with more power, it's going to take longer to come back down, until eventually you shoot the cannonball fast enough that it escapes the Earth's gravitational pull and never comes back down. So when a star of over 25 solar masses dies, while it's collapsing into itself, its gravitational pull increases. And it keeps increasing to the point where nothing can escape the gravitational pull, not even light. That is to say that if you were inside a black hole and a photon is your cannonball and you were to flash a light upwards outside of the black hole, it would just simply fall back in. So black holes are points in space with infinite densities, with the gravitational pull so strong that nothing can escape, not even light. But what does that mean in terms of the geometry of space? If you watched my video on gravity, you now know that gravity is the consequence of the curvature of space-time caused by uneven distribution of mass. What a black hole does is that it creates an infinitely deep hole in the fabric of space-time. So the curve it creates is infinitely deep. Now you may ask yourself, if nothing can escape the gravitational pull of a black hole, then why isn't the whole universe in a black hole right now? This is because of the way black holes are structured. There are three main parts of a black hole. First of all, the singularity, which lies at the very center of the black hole. It is the point of infinite density, where all the mass of the black hole is squeezed into an almost zero volume. And then there's the event horizon, which is the point of no return. Anything, literally anything that surpasses that point will fall into the black hole and will never come out. The last main part of a black hole is the accretion disk, which is a spiraling disk of material, dust, and interstellar gas spiraling towards the black hole. There are four types of black holes: stellar black holes, intermediate black holes, miniature black holes, and finally supermassive black holes. We're going to be focusing on stellar and supermassive black holes, as the other two are pretty self-explanatory. Stellar black holes are the black holes whose formation we explained earlier. They get created from stellar death, and their masses typically vary between 5 and 10 solar masses. Supermassive black holes are the largest known black holes, and they live at the center of galaxies. These black holes have a mass that ranges between millions to even billions of solar masses. There are several theories on the formation of supermassive black holes. They may come from the collapse of very dense stellar clouds, or they may be the result of collisions of multiple stellar black holes. But what happens when you throw something into a black hole? Let's see. When you burn a book, the information of the book doesn't disappear. It just turns into ashes, but the information is still there. The universe likes its information. It doesn't like to create new information, and it doesn't like to destroy existing information. But again, what if you throw that book into a black hole? In the 1970s, Stephen Hawking discovered that black holes aren't actually entirely black. They actually emit radiation known as Hawking radiation. He showed that black holes can evaporate, that their masses can be turned into energy, and that energy can leak out of the black hole. So, if the information didn't leak out with Hawking radiation and the black hole goes away, then what happened to the information? This is known as the information paradox and is yet to be solved. What's interesting is that scientists have a pretty clear idea of what would happen if you were to fall into a black hole. What happens is that the gravitational pull at your feet will be so much greater than at your head that you will literally stretch and form a spaghetti in a process known as spaghettification. But black holes are still one of the universe's biggest and most fascinating mysteries. So I'm here to tell you to stay curious. Thank you all for watching. I hope you enjoyed this video. If you did, please like and subscribe, as it means a lot to me. If you have any questions, leave them in the comments below and let me know what my mic sounds like, if it's good or bad.